So we have to performing the half adder for. So first you have to select the new source, select verilog module for the module program. So I can give the name for half adder. So that's why we are using the half adder program. So half adder here is a representation for the module name. Then you have to select. Okay, so already name is there. So for in case of the half adder, I have to use the input variable say comma b and sum and carry is the output variable. So you have to select a comma b is already input to default. So you can select output for carry as well as sum. Then you have to click on next. We can get like this window. So here obviously we can get the code by default by using the styling software. Just we have to simple code assign sum. So sum is nothing but sum of a comma b is in case of the half adder that is equal to a XOR b. That is our equation we can performing after k map representation, as well as assign carry is equal to a and b. So ab is a product, so product operation can be performed by using the and operator. That's why you can represent this ampersand is used for representation of the this symbol used for product operation. This is used for XOR operation, the A and B. So this is a simple code. So first of all, you have to check this code is correct or not. So for that purpose, check syntax. You have to click the check syntax. If it is correct, it can be represented by the some green tick mark in the check syntax. In case if you have any errors, then it can be represented by the like errors in the console window. So we are checking right now regarding the errors for this syntax errors. The process is still going on. So this code is correct because of we are getting the green color tick mark. Now you have to write the test bench program. So what is meant by test bench? Test bench program means that we can give the input for the half adder. So what are the different ways of combinations we can produce? We can give the input for the half adder. So that is the main intention of the test bench. So for that purpose, you have to select this. Just you can click on the corresponding module program. Select new source. We are writing the test bench program. So verilog test picture is there. So correspondingly we can mention half adder test bench test bench program, right? So for our representation point of view, we don't have any consideration here. Just for our convenient point of view, we can give the names regarding like this. So after we can select the source with a I mean if you want to write the test bench, so obviously we have a number of options will be there, but we have a starting program is this. So for that purpose, half adder program, this is a module folder module name in case of the half adder we are giving, right? So click on finish. We can get the combinations. So by defaultly we can get some of the code like this. So module test bench name, so that is already given in the previously, right? So register A and B, so reg and A register. So reg means it is a register type variable A comma B. So register type variable means that if the variables are used in the procedural block, that may be initial block or maybe always flag flow left side of the in case if you are using a comma b in the left side of the procedural block, obviously we can represent that variables in the form of a register type. So here initial is a procedure block. So this and in this case a comma b are using in the left side of equal to. So that means if you are using the variables in the procedural block in the left side, that variables must be a register type. So there is a, so for that purpose you have to represent reg and b, and y is a output point of the representation. So in case of the half adder, we have two types of output, that is nothing but sum, and second one is so for that purpose we can represent output can be represented in the form of a y representation. So half adder program unity. So this is nothing but module name in the already given in the previously. So in this bracket also there is a half adder, right? So this is for the representation. That means we can call instantiation means whenever we can represent the module name, obviously that copy of the operation can be presented in the test bench itself. So for that purpose, this is a better way of representation. A dot of A dot B of B sum dot of sum of sum. So this is a combination. So initially they can give A is equal to 0 and B is equal to 0 combination. So what is the remaining combinations in case of the half adder? So A is equal to 0, 0, 1 combination, A is equal to 0 and B is equal to 1. After that we have to perform 100 seconds nanoseconds delay. Then another combination A is equal to 1, B is equal to 0 combination. After that perform take a certain delay of 100 nanoseconds. Then last combination A is equal to 1, B is equal to 1 is a different ways for giving the. So in case of the half adder we are giving the input for two inputs only. So in case of the digital, obviously the input may be 0 or it may be 1. So based on that consideration, a comma b values can be given in the four possible ways for the two variables. So 0 0 0 1 1 0 1 1 right here. So this is a test bench program. Now we have to check whether this program is correct or wrong. So select the test bench program, as well as assimilator is also activation there. Check behavioral syntax. Is there any errors are there? In case if is there any errors, so obviously it can be represented in the form of a uh, red color tick mark. So it is a correct. So that's why it can get represented in the green color. After that we can perform the simulation operation. After performing the simulation behavioral model, which will give the results in terms of a graphical representation. So our output is also correct, therefore it can be replaced. So just you have to select this window. So first of all you have to check a comma b, that means input a b values and some value carries out. So initially in case 0 0, addition of those two 0 0, some value 0, carry value 0. Suppose a is equal to 0 and b is equal, that means addition of 0 comma 1, that gives the some value 1 and carry value 0, therefore some value 1 and carry value. So here obviously this graph high means that it can be enabled high. So this horizontal line represents a 0 value. Is there any high in the corresponding? There is a transition. So in case whenever you will click this yellow mark, obviously that values can be represented here. So 1 means that some value 1, right? So if you are clicking carry value 0, means carry value 0. So for the next combination, in case A is equal 1, B is equal 0. So 1 0 combination, so we can get some value 1 as well as carry value also 0. So the last combination is nothing but 1 1 consideration. When A is equal 1 and B is equal 1, at the time some value is equal 0 and carry value is equal to 1. So this is, that means this truth table of the half adder is perfectly verified by using this graphical analysis. So this is if you are writing the code in case of the verilog, obviously it performs the evaluation based on the corresponding input combination, which produces the output in terms of a graphical representation. I think this video is very helpful for you to write the program by using the verilog, right? So thank you for watching GMK tutorials. Thanks a lot.